All right, so today we're going to be looking at section 2.4, graphing piecewise functions. So let's talk about what is a piecewise function. A piecewise function is a function that is defined by two or more equations. And so on this first example, we can see here, we've got a constant, and then we have part of a quadratic. So that's two different pieces. Here we have 1, 2, 3, 4, 5 different pieces. And it looks like over here we've got 1, 2, 3, 4, 5, 6 different pieces to the graph. So it's still a function. So since I say that, I wanted you to pay close attention to here. Notice this is an open circle and this is a closed circle. That way, it's still a function. If we did our vertical line test, it only passes through this point because this point is open. And so these are still functions. And so it's just two or more functions put together to create a bigger function. That's all the piecewise function is. So we can look at these piecewise functions a couple of different ways. I can give you your set of equations, and notice whenever you're given the set of equations, here you have the function itself, x plus 4 is the function, but it also restricts the domain. This is a restricted domain, because it doesn't want the entire line. It only wants the x values that are less than or equal to 1. For the other piece, the 8 minus x, we're restricting that domain for all x values greater than 1. And so when we come over here and we're looking for g of negative 4, we have to decide, where does that negative 4 fit in? Is negative 4 less than or equal to 1? Or is negative 4 greater than 1? Well, we know that it's less than or equal to 1. And so that's when we're going to use the x plus 4. So we're going to use the x plus 4 function. And we're plugging in negative 4 for x. So g of negative 4 is 0. Where is this x value? 0 is less than 1, so I'm going to use the x plus 4 again. 0 plus 4 is 4. So g of 0 is 4. When is x equal to 1? This one can kind of be a little bit tricky, because notice here we have less than or equal to 1. This one is just greater than. Our second equation is just greater than. So because this is 1, we want to use the function that has it equal to 1. So again, we're going to use x plus 4. And x is 1. So 1 plus 4 is 5. So g of 1 is 5. The next one, where x is 3. Well, 3 is greater than 1. So we're going to use the 8 minus x function, which is going to be 8 minus 3, which is 5. So g of 3 is 5. And so it's all looking at what they're asking you for and which piece of the graph it fits into based off of your restricted domain. Here we have 3 different pieces of a graph. And so I kind of like to come over here and say, all right, I've got x less than negative 2, Here, this means that x is in between -2 and 4. And this is saying that x is greater than 4. So remember, these are all my x values. We talked about that at the beginning of the unit. So now I just have to figure out which equation goes where. I'm going to call this equation A. I'm going to call this equation B. And I'm going to call this equation C. So -4. -4 is less than -2. So we're going to use equation A for this one. So I've got -5x minus 8. So -5 times -4 minus 8. What is that? 20 minus 8. So f of -4 is 12. -2, it's kind of tricky here because we have a -2 here and we have a -2 here. But remember, this one is the one that it's equal to. That's the one that it's equal to. So we have to use equation B. So 1/2 times -2, I'm going to put -2 over 1 plus 5. Let's see, that gives me -2 over -2, which is just 1 plus 5, which is 6. So f of -2 is 6. I just lied to you. That's not negative and negative. That one's negative. Sorry about that. At least I caught it. -2 over 2, which is -1 plus 5, which is 4. I'm glad I caught that. Again, f of 4, we have to pay very close attention because here we have a 4 and here we have a 4. But recognize this one has the equal to, so we'll be using equation number B, or equation letter B again. So that's 1/2 times 4 over 1 plus 5. That gives me 4 over 2 plus 5, which is 2 plus 5, which is 7. If you're wondering where I'm getting this 4 over 2, since we're multiplying fractions, multiply fractions, you just multiply your numerators, multiply the denominators. And then 6 is greater than 4. So I'm going to use equation letter C. So 10 minus 2x. So 10 minus 2 times 6 is 10 minus 12 is -2. So that's basically just being very careful in choosing which equation you need to use. Okay, so here we're actually going to start graphing these. The biggest piece of information, the domain of each piecewise function is going to be all real numbers. It's going to go from -infinity to +infinity. And so that's a good piece of information that we have to have. And then we're going to graph each function, and then we're going to use the graph to determine the function's range. So there's a couple of different ways you can do this if you are just a rock star at graphing lines, and you can look at this because this is essentially y is equal to 2x. And so with that, I know that I have a y-intercept of 0 and a slope of 2. And so if you can do that, then yes, you can do that. But if you can't do that, then we need to have a different way of working these problems. And so what we're going to do, like I said, if you can do that, more power to you. But what I'm going to do is I'm going to say we have y is equal to 2x. And I'm going to build a table. And I'm going to choose x values less than or equal to 0. Why am I choosing x values that are less than or equal to 0? Well, because that's what it says right here. So I'm going to choose 0 first, and then I'm just going to do -1 and -2. You don't have to go crazy. You can just pick 2 or 3 points. And so then what I have to do is I have to take each one of those values and plug it in. So 2 times 0 is 0. 2 times -1 is -2. 2 times -2 is -4. And so those are the points I'm going to graph. I'm going to graph 0, 0, -1. I don't know why my highlighter does that. I'm going to graph the point 0, 0. I'm going to graph the point -1, -2. And I'm going to graph the point -2, -4. So over here, 0, 0, -1, -2, and -2, -4. And yes, I see that my graph was wrong from the beginning. And I'm making sure that this one at 0, 0 is closed because right here it's closed. Okay, so there's the graph. Y is equal to 2x if x is less than or equal to 0. And I know it's connected. I know it has an arrow at the end because it clearly said that the domain is going from -infinity to +infinity. So this next one, we have y is equal to 2. So I'm going to build my table, and I'm going to choose x values greater than 0. So I'm going to choose 0, 1, and 2. Well, no matter what x is, my y value is 2. Because that's what my function tells me. So 0, 2, and I'm going to ask you a question. Is this going to be open or closed? It is going to be open because it is not equal to it. At 1, I'm at 2. At 2, I'm at 2. At 3, I'm at 2. I could go on forever. And so there is my piecewise function. I know that the dots connect, and I know that it keeps going forever, that there's an arrow at the end of it, because my domain specifically said that my domain is all real numbers, that it's going from -infinity to +infinity. Okay, here we go again. Again, it tells me that my domain is all real numbers. I need to get that a little bit thicker. And so my first equation is x plus 3, and that's for all values of x less than -2. So I'm going to choose -2. I'm going less than -2, which is -3, -4. Now I'm going to plug in Negative 2 plus 3 is 1. Negative 3 plus 3 is 0. Negative 3, nope, not negative 3. Negative 4 plus 3 is negative 1. And so again, I'm going to plot these points. Negative 2, 1. It's going to be open. Negative 3, 0. And negative 4, negative 1. And there is the first piece of the graph. The second piece of the graph is y is equal to x minus 3. Building my table. This time I'm going to choose x values that are greater than or equal to negative 2. So I'm always going to choose negative 2. And to be bigger than, I'm going to go to the right, so negative 1 and 0. And you don't have to choose the values right next to it. As long as it's bigger than negative 2, it really doesn't matter what values you choose for x. I just kind of go in order. So let's see. I get negative 2 minus 3 is negative 5. Negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. And so I have to point out here, when x is equal to negative 2, that is going to be a closed dot. So negative 2, negative 5 is closed. Negative 1, negative 4. 0, negative 3. And there's my piecewise function. Oh, we forgot to do the range. Finish up this one and we'll go back to the other one. So the range, remember, goes from the bottom to the top. But you have to remember, you've got these arrows on the edge here, on the ends here, that mean it's going to continuously go forever and ever and ever. We know that the domain is all real numbers, or negative infinity to positive infinity, and this one is also going to have a range of negative infinity to positive infinity. Let's go back and look at this one. So the range for this one is going to go from negative infinity to 0, and then it's just going to be the number 2. Because we have all these points along the yellow line. And then on these, my y value is just going to be 2 every single time. Okay. Here I have 3. So I'm going to have y is equal to x plus 1. And I'm choosing values that are less than negative 3. So I'm going to choose negative 3, negative 4, negative 5. I'm plugging in those values. Negative 3 plus 1 is negative 2. Negative 4 plus 1 is negative 3. Negative 5 plus 1 is negative 4. So when I go to plot these points, is that going to be open or closed? It'll be closed. When x is equal to negative 3, it will be closed. So negative 3, -2 is closed. -4, -3, -5, -4. There's our first piece of the graph. Our second piece of the graph, y is equal to -1. And I want to choose values in between 3 and 4. But I'm going to choose -3. I'm going to choose -3 and 4 because I need to know what's happening at those endpoints. And so I'm just going to pick 0 for the middle. So it really doesn't matter because no matter what my x value is, my y value is going to be -1. So -3, -1, and that one's going to be open. Zero, -1 is closed. 4, -1 is open. And there's that piece of the graph. And last but not least, I have 1/2 x, building my table. I'm going to choose values that are bigger than 4, but I'm also going to choose values that are even. And I say even because if I have to multiply it by half, I don't want to have to deal with fractions. And so at 4, I know that this is going to be closed. So half of 4 is 2, half of 6 is 3, half of 8 is 4. So I've got 4, 2, and I know that it's closed. 6, I'm at 3. And I'm already off the graph. And there is my piecewise function. Now the range on this one's going to be a little tricky. The range here, because we have 3 different pieces of the graph. And so for the blue graph, we're going to go from -infinity to -2, parenthesis bracket. We're going to union that with the number -1, and we're going to union that with 2 to infinity. This range is from -infinity to -2. This range is just -1. This range is from 2 to infinity. Remember, we're looking at range, so we're looking at y values. I hope this helps. If you need anything else, please let me know.